So today I'm going to take you through MS Access 2016 and SQL using MS Access 2016. So this is a total guide including practical sessions which covers SQL throughout SQL, and we are using Microsoft Access 2016 to cover from A to Z. So this is a 3 to 4 hours learning session where you master all the concepts of SQL using Microsoft Access 2016. So I think let's start. So let's see what all sessions we are going to cover in this complete SQL tutorial. So you can see here the first we'll cover Access overview, then the relational database management concepts including data definition, data manipulation, and data control. Then the MS Access common objects that we use like table, and using SQL how you can query from tables. And then we set up forms, reports, and other MS Access objects including some basic macros or some basic automated thing that you do in MS Access. Then we go to creating a complete blank database. From a blank database, how we can create a complete database, then different data types that we use in that, and then creating tables using design view, then adding data, querying data as you told. So detailed section covering query criteria, action queries, like an append query or an update query, then different queries like MakeTable queries and all. Then like parameter queries, alternate queries, and relating data using normalization, and how you can define relationships between tables, from one table to another, one-to-one relationship or one-to-many relationship. So how you can do that, in some simple steps. Then you can see the number of relationship one-to-one. I'm going to cover one-to-one, one-to-many, and many-to-many relationships. Then how you can search using wildcards, symbols like asterisks and all, how you can search in a database. You suppose if there are names starting from A, or if you want Adam to be searched, how you can search it by just providing AD and then a star. That's a wildcard. So that will be covered with a practical tutorial for each and every session. And then calculated expressions, other than the predefined ones, how you can do the calculated expression. Then indexing is a very important topic that every engineer or every SQL computer science aspirant should know about. Indexing is very important in all the SQL, whether you are using like MS Access or Microsoft SQL Server or MySQL or MongoDB, whatever it is, whatever database that you have, indexing is the most important concept that you should master. So the your query runs, the speed of your query, everything depends entirely on the indexing. So that will be covering. I'll be showing some practical examples. Then the grouping of data like aggregate query, then summarizing the data like joins. So what is a join? So including left outer join, right outer join, then self joins, etc. That's also a very important concept, for all the databases, or SQL Server or MySQL. So joins are very important. So you should also master that. Then duplicate query wizard, how you can figure out duplicates, or unmatched query, from one, if there are two tables, how you can find, whether there are like unique records that's pertaining to that particular table only. So for that you can use unmatched query. Then creating different forms, different types of forms, split forms, multiple forms, and all those. Then modifying a form, navigation forms, combo views. Then the more important concept, or the most important concept, is like SQL view in MS Access, where you can type your own queries, uh, rather than depending on the user graphical user interface. You can just type in, if you are if you are well known to queries, definitely how you can write, SQL select queries or append queries or update queries, so whatever it is. Then MS Access, how it is formatted, based on that. Suppose if it's from an Excel sheet, how you can import, based on the formatting. Then formatting reports and reporting basics. Then some built-in functions, like date function, date difference. All those functions will be covered. Then of course, similar to Excel, you can create your own like automated tasks or automated coding under macros. How you can create a basic macro, that will be covered as well. So, and then another one is import, data import. As I already explained, you can import it from different Excel formats or other database formats. So I'm going to explain to you using a real example on how you can import or create a new table, or connect to Excel, or create a new table with Excel wizard. Then MS Access data export. Export is of course exporting, as you know, you can create your own reports from that. So these are the topics that's going to be covered, and Let's start the session. So for that, I'm going to create a test access database. Now, before going on to creating a sample database, I'll just explain what Access is. It's a database, DBMS, from Microsoft, that combines the JET database engine. So that's what is used. It's a relational database engine. So, okay, so that's how it is. So it's an RDBMS as it's mentioned, it's an RDBMS. There are different query languages like data manipulation control. Then, as I explained, there are like tables, queries, forms, and reports in database. So let's start by creating a table. Okay, so let's start a sample database. I'm going to open MS Access. I'm using Office 365, so I'm going to create a new sample data. Is a blank database I'm going to select. I'm going to name it as test database 1.acdb. So ACDB is the recent format. No, in the previous version, in the older versions, we were using MDB format. Now it's ACDB. Yeah, to create. Perfect. So we have our first table. So this is not the table format that we need. So for a table, we need to have different formats, like name for the different data types are required. So we'll right click here, then design view. I'm going to rename the table. Okay, so I'm going to rename the table as my test or TBL1. We can okay TBL underscore test one or TBL underscore first. That would be good. And always keep this in mind, while you are renaming or naming a table, don't put uh, blank spaces. So this is like table underscore first. I'll explain to you why you shouldn't or you must not put blank spaces in renaming a table, because you need this table name in many queries, in SQL statements. So that time, if you put a blank, it's very difficult, to write a query. So that's the reason why I always prefer you to have a special character, of course, table underscore first. That's a perfect naming method or naming convention. So I'm going to create my first table. Yeah. Now let's see. Let's select. So auto number. So these are the field names that you need to set, and based on that, different data types. Of course, it's an optional description that you need. Okay. So auto number, I'm putting a description as system generated number, random numbers, right? Yeah, or sequence numbers, whatever it is you can type. Then I'm going to put name. Name should be short text. Let's put it short text. Then maybe if it's an employee, definitely an employee will be having an employee number. Employee number. What is the employee number? Can be a number format. If it's a combination of both number and text, you can put it as a short text itself. That's fine. Then you can type maybe country, or he's a citizen of which country. You can put as like this. Okay, citizen can be short text. Citizenship. Then maybe date of birth, DOB. You can just put it as DOB. Okay, so we have it here. So DOB, date of birth should be date of time. Okay, can put the description as date of birth. So you can write anything in the description box. That's for your future reference to identify which columns are for what. What are the tasks assigned for that particular column. Yeah, that's what it is. Okay, so we have it here. Now the unique name should be ID. So we have put it's automatically assigned, the primary key. The primary key should be the one that's uniquely identifying the records. You shouldn't have primary key duplicated. You should never have it. You will never have it. So that's how database is designed. Either you can specify your own custom primary key. So here what I'm going to do is I'm going to delete this primary key of, yeah, I'm going to assign my employee number as the primary key. Yeah. So because employee number is something which basically should be assigned or uniquely assigned to a particular individual or a particular employee. So here I'm going to put, yeah, this as the primary key. So that's fine, employee number. So this is my custom primary key. So primary key, as you know, people who are just the beginners. For the beginners, I would say primary key is something that uniquely identifies the database records. So suppose if there are 100 employees, 100 employees will have 100 unique IDs. That's particularly assigned to them. So that's unique for them. Yeah, perfectly. So we have our first set of fields ready for the database. So let's save this database and then right click and go to datasheet view. See this. Yeah, we have the ID, we have the name, we have the employee number. Let's just expand this. Yeah, then the citizenship and then the DOB, date of birth. Let's see, let's put some random values. Name can be ABC, or maybe we can assign a common name, general name, John. Yeah, employee number, 1, of course, or some random number like 100. We'll start with 100. Citizen, maybe, let's say US, of course, United States, John. John's date of birth. Since we have assigned date as the data type for DOB, if you click here, you can see this, a small pop-up. Click that, then you can select the date of birth. Maybe if it's like Jan 1 2000, or yeah, let's say Jan 1 2000. You can also edit it 2000. Perfect. Ensure that it's in the right format. John Wick, let's say 101. As you see, this ID, it's an auto number generated, which identifies the record. But we haven't assigned primary key for this ID, so we wanted employee number to be the primary key. Yeah, maybe citizen of France. Mm, date of birth can be August 1, 2000, let's say 1999. Perfect. So we have our first set of table or first set of records ready. Let's put some one or two random values as well. To Germany. Let's put 89. Let's see. It should be. Now, one more thing I wanted to tell you. So, what if you put the same employee number, because we have assigned a primary key for this employee number. So let's take, I'm putting 101 again, and some maybe Germany. 91. What happens? Perfect. You can't create a record because it's violating the primary keys rule that you should have a unique employee number. So definitely you are not bound to make mistakes, even like what you call, not deliberately, undeliberately, or by mistake, or by typo error. It's not going to happen. So access is ensuring that. So you can see that the changes we requested to the table were not successful because they would create duplicate values in the indexes or primary key or the relationship. Change the data in the field or fields that contain duplicate. Definitely I'm going to change it. Let's put 103, which is a unique value. Perfect, it's created. Now let's save it and close it. So we have our first table ready. Yeah. Now I'm going to add one more table, maybe a table project table, so that we need to, delve deep into the concepts of SQL relationships and all those. So let's take maybe a new table, definitely create. So you can see here they have creating a table section, query section, forms, reports, and macros and code. So all the 5 topics are going to be covered thoroughly in this SQL tutorial or access tutorial. So let's take table. Yeah, perfect. A new table I'm going to create. Right click. You can also create table design, but I prefer this method. Table design view. I would say tbl underscore projects. Perfect. I'm not going to put an ID here, so I'm deleting this one. Yeah, I would say project ID can be number, project underscore name, short text, So employee number. So just see this. Okay, employee number. Okay, it's going to be number, and then budget. Okay, let's have some budget field, maybe in currency. Hmm, yeah, of course, currency. Let's see. uh, then let's put the currency in US dollars. Perfect. Budget. Sorry guys. Then what else? Extra notes. Extra notes, maybe long text where you can type any notes, regarding the project. And now here I'm going to assign project ID as the unique number or primary key here in this table. You know why? Because so you might be wondering, okay, why don't we put employee number? It's because a single employee might be assigned to multiple projects. So putting an employee number as a primary key here is not at all advisable. So you can't do that, this will reject it. So I'm putting project ID because only for every project or every single project there will be unique project IDs. So let's put it like that, either you can put auto number, as and when the projects are added, it gets automatically added. So let's put some auto number. Okay, yeah, let it be the project ID. Perfect. I'm closing it. Now I'm adding some data to the projects. Okay, project name can be Microsoft project Microsoft learn, or what you call, maybe automation project can be, right? That's the buzzword in the corporate world now, automation. So let's put it. Employee number we can later assign. So budget can be. So now here I am putting as rupees. Okay, so budget I am, let's just 1000. Yeah, extra notes, nothing as of now, not applicable. Now second one, mm, implementing new, what you call, cost saving project A. Project A. Okay, let's assign the values for these projects later. Okay, so for the time being I'm just randomly putting some projects. Project B, project C, and project D. So let's assign employee IDs later. Okay, or you want me to assign it here? Definitely we can add it. So we know that there are like 4 employees now in our company, so let's assign John to project A and B. 101, 101. You got it. The reason why I haven't made employee number not a primary key or a unique number here, yeah, because John is assigned to project A and B now. Yeah, John or Vic is assigned for A and B. Now John is assigned for here, not the other two guys. Let's put them here. Okay, 113. Perfect. So we have our projects table ready. We have our first table ready. So we have covered the sessions like creating the database, data types we have covered, tables we have created, design view you have created, tables, then adding data. So we have added data for 2 tables, table projects and our first employee table. Now what we are going to select or what we are going to learn is querying the data and different query criteria and different types of queries. So let's move on to queries then, right? Yeah, perfect. So you people can try this out along with me, I believe you people have created both the tables that I have mentioned. Now let's start querying data. Yeah. So let's create a select query first, select queries used to get records based on a criteria. Yeah, let's go to create now. Here it's create, query wizard and query design. Let's go to query design, a new blank query. I used to prefer query design rather than query wizard. Yeah, so let's say we need to select some records from the first table. Okay, let's add that TBL first. Yeah. And I wanted to select based on a criteria or based on the values here. So I prefer you people master the skills of SQL than going for this user interface. Okay, so I always prefer. So throughout my tutorial, you will find me using more often 90% of the time. I'm using the SQL view. So here in the view you can see SQL view. Okay, and I have selected select. We are going to use select SQL queries. Yeah, SQL view. Now select what from table first. So if you put a select star, it means you will select all the records from that table without any using any criteria. Let's run the query now. Yeah, click here, run. See this? So if you run the query, you got all the values, all the records are returned. Now let's go back to SQL view. Yeah, the SQL view, what I'm going to select is, okay, select star from table first. I'm putting a word condition, a condition. This is called conditional queries, conditional select queries, where let's say name, name like a star, or let's go to something much easier first. Okay, select top, select from table first, select all the records, or select name. Let's select only name. Okay, name from table first. I need to know who is on employee ID equals 101. So do you think this code is going to run? Let's say it's going to return no values. Why? Because we don't have an employee ID. Hope you got it. We don't have an employee ID. We have employee underscore number. And you should follow the caps lock, everything. So E should be capital, N should be capital, and everything should be perfectly written. Employee underscore number. It's not employee ID. Okay. Employee underscore number. Let's see. Now let's run it. So in the design, select one. Data type mismatch and write the expression. Because why? Number, again, one more thing. So that's the reason why you deliberately put the double quotes here. So you have selected employee number as a number format data type. So you cannot put double quotes here. So double quotes is used when there is a character that you need to search. See this? Week. Let's analyze it. Week is 101, right? Yeah. Because we selected only the name, it returned the name. Now suppose we have selected name as well as employee, what do you call, or a citizen. Yeah, we need to know name, comma, citizen, right? Citizen should be capital. No, C should be capital. That's it. Citizen. Perfect. Let's run it. The design run. We got the citizenship of Nick, who is who is having that employee ID 103. Or you can specify some other criteria where the employee number should be greater than 101. Let's see what it returns. It will return. So as per our knowledge, it should return 102 and 103, right? So both Kriti and manual should be returned. Let's see if it's returning Kriti and manual. Perfect. So this is how you master select queries. I hope you got a glimpse of select query. Okay, let's name the query. Our first select query, right? Select query. So let's put it QRY in this format. I always prefer this format. QRY underscore select one. Our first select query, right? Yeah, perfect. I've saved it. So if you see here, the access objects are aligned based on the objects. Like if it's a table, it will be coming under the table criteria. If it's a query, it will be coming under queries. If you create a form, it will come under. So like how this is arranged. Let's save it. Close it. Don't need this now. Yeah, we closed it. So now we have seen query criteria, select queries. Yeah, select queries is what. Now query has another function. Why we need queries? Because by the passage of time, definitely your records will grow in numbers. It will grow up to like hundreds of records or millions of records in the time. So what happens, you cannot return all the values as such. So you need only some specific records based on your criteria, based on your requirement. So there comes the select query. You can select only some records based on your value. Suppose if you want to know like employees who are working on a particular project, how will you get it? You just need to create a select query. You don't need to return all the 100,000 records as such, and then you need to figure it out from one by one. No, you don't need to do that. You can just create a select query based on the condition and based on the criteria that you have specified. It will return in like seconds. So, so that's the purpose. That's the power of having SQL. SQL is commonly referred to as SQL. Yeah. So that's how it is. Now we have covered create select queries and so the basic queries that we have covered. So you people can you know practice it on your own. Okay, what are the queries, different select queries by putting different conditions. So I always prefer you go for the SQL view rather than this design or the user interface, this graphical view, because graphical view is not good for people who wanted to learn SQL in the long run. Because if you learn using SQL view, you can master any database language, whether it's MS SQL Server, any platform you can use, or MySQL or Oracle, whichever you prefer, you can do it. The concepts, the underlying concepts are the same, but you need to learn from the SQL view only. Yeah, so that's how you should be learning. Now we have covered the select queries. Now we'll move on to action queries, action queries. So action queries are there in all the DBMS, SQL Server or whatever it is. So there are four different types of action queries. So one is append, then update, delete, and make table. Okay. So the problem with action query, or the major difference between action query and the usual select query is action queries are permanent. Yes, you heard me right. So once you make a action query, or once you run that query, the changes that you make in the database are permanent. It's not temporary. Yes. So select query is not affecting your database values. It's just retrieving the data and showing it to you in a presentable format. That's it. It's not making any changes in the underlying data. But action queries, as the name suggests, it's acting on the database. It's going to change the values permanently. So before you do an action query, 100% ensure that you are using it properly, especially if you are doing it on a live database. I would always prefer you go for a test database first, run the query, and see how the values are getting affected. Only then run it in the live database. So that's the power of action queries, but that's very much required. These action queries are the most important ones, that you need in your day-to-day life. If you are designing a database, or in a corporate world, definitely if you are designing some database in SQL, or if you are designing it in MS SQL Server, wherever it is, the action queries are the most important ones. So let's first start. I will say that, let's start with delete query first. Okay, delete is a more easier query than, okay, let's see delete query first. So let's create a delete query. Now let's go for a query design, create query design. I'll take the first table itself, yeah. Now instead of select, I'm going to click this delete. Perfect. I selected delete now, and I'm going to SQL view. Either you can right click and go to SQL view, or here in the view you can go to SQL. Now delete star from table first, it's automatically come, So this means you are deleting all the values. So delete star. The star is a wildcard which is used to select all the, but we haven't mentioned any criteria. So it's going to delete all the values. So we don't want that, okay? So we just want to delete maybe an employee number. Let's see, table first. I wanted to delete anything greater than 102. Any employee number greater than 102, or maybe let's say any employee number greater than 100 and less than 100, or less than 101. Let's put a criteria like that in our delete query. Yeah, where employee number less than 101. Let's run it, guys. Design, run. Employee number, again we have misspelled it. Yeah, running it. So you'll get a warning like this. Since it's an action query, you know that the changes are permanent. So it's telling that you are about to delete one row. So always check this value, okay? So if there are like two records which is going to be affected, it will show the number, okay? Number of records it's going to affect. Now it's showing only one row will be affected, or one record will be affected. Okay, since we know that, we are going to delete that record 100. John's record. Okay, we know it. We click yes. Now the action query is run. Okay. Now let's see this. John is gone. Perfect. Now we don't want that to happen, so let's put John back. John is like 100. John United States. Some random 1991. Hmm. Perfect. We put it back. So this is our first delete query. So I'm going to save it as query underscore delete one. So we have our first action query. So that's delete query. So we have demonstrated how it is working. Hope you got a glimpse of how you can run the delete query. Now next time when you wanted to run this query, just double click this. It will delete any records which are less than 100. So if you wanted to delete any after archiving, if you wanted to delete all the archived ones, suppose you're deleting like all the employees who have joined before 2000, you need to delete all their records because you have already archived it. Definitely you can write a query like this, save it here, and then run the query. That's it. So delete query is taken care of. So let's move on to append query now. Append query, as it suggests, used to retrieve data from one or more tables and then adding that data to another table. So let's create a temporary table now in our test database. So let's create a temporary table now. Okay. So temporary table, you can just rename it as TBL temporary. Yeah, temporary table. And then let's define some fields, we don't need, can even create tables without using a primary key. Okay, even that's allowed, yeah, but even though that's not a best practice to implement. Yeah, let's say employee number, can be number, then citizen. Okay, citizenship can be short text. Let's say reviewed, can be auto number or a lookup wizard. So no, yeah, let's put it like yes or no. Yeah, let's have a temporary field like this. Now in the temporary field we don't have any values. Okay, I'm using an append query to input data from this table first, this employee number and citizen who are like more than what you call the employee number is greater than 102. So we are going to use an append query. Okay, now we are creating an append query, create, then query design. Then let's select the two tables, the table from where you are retrieving the data, or the tables from where you are retrieving the data, and the table in which you wanted to append the data or add the data. So we are selecting both. We are selecting TBL first, and I am holding the control key in my keyboard, and then clicking on the table temporary as well. I'm adding both. Yeah. Now, so the select is what you call automatically selected. Now we need to move on to append query. We have completed delete, select, and now we are moving on to the append. I'm selecting append. Now append to which table? Let's say table temporary. Okay, let's select SQL queue, insert into table temporary. Okay, design view, insert into table temporary. Yeah. So I'm inputting employee number from table first to employee num in table temporary. Similarly, I'm inputting citizenship DBL first. Citizen from table to citizen here. So it's automatically selected. The names are similar, so it automatically selected. If you want to select something else, yeah. Now I'm not just limiting this append query to this. I wanted to input some criteria as well. So I'm selecting SQL queue. Now if you see this, insert into table temporary employee number and citizen, where select DBL first employee number citizen from employee DBL first. Where I'm putting where DBL first dot employee number. Okay, I'm putting DBL first dot employee number. So the employee number should be greater than 102. Okay, I'm closing this query. Let's run. We are about to append one row. So table from the table first we are inputting or we are appending data for the employee greater than 102. So there should be like one employee, right? That should be appended to table temporary. Let's see. I run the query. Now see the table temporary now. Yeah, employee number 103, Germany is being moved. Yeah. Now we reviewed it, we just selected yes. Perfect. So this is how you input data from using append query from one table to another. Let's save it. Okay. Now query our first append query, right? Append one. It will go to the query section. Yeah, append one. Perfect. So next we are going to see update query. So now append query is done. Now we are going to move to update query. Perfect. So how do you create an update query? So how do you update a query? Now update query is nothing but it can change the value in a table based on a given criteria. Suppose we are adding some assignees, okay? Jim with 106, let it be like 104, 105. Need not be like, in sequence. Jim core 106. We know that, in bulk we are adding some employee names. Okay, so we are adding some employee names in bulk. Oops, I forgot. See, yeah. So we have added some names. Okay. Now in bulk, now for all the names that we have added now, anything greater than 103, we know that they're coming from or they have the citizenship of what you call maybe we'll say Italy. Okay. So how do you input it? So is it possible that if there are 100 records like that and you wanted to type Italy, Italy, Italy for everything, it's not possible, right? It's not actually possible. Practically, it's impossible. If there are 100 records or 1000 records, you need to update a value. Now, what do you do in such situations? So for that, we have an update query. So I'm going to create an update query for that. Okay. Now we have seen select, we have seen delete, we have seen append. Now this is update query. Now I'm selecting the update query here, and I am going to SQL view. Now update table DBL first set. So you can see here update table first. Now set is for setting a value. Set, I would say citizenship, right? Now what is citizen? Set, yeah, DBL first dot citizen. So you should always mention that table name DBL underscore first dot the value citizen equal to. So since this is a character, we need to specify it in double quotes. DBL first dot citizen is equal to Italy, right? Now we are specifying a condition where employee number table first dot employee number, right? You can put employee number since there is only one table you are selected. You can easily put employee number, but I always prefer you put the table name and then a dot and then employee number is greater than 103. Perfect. Now let's run it. Let's run it, guys. You're about to update 4 hours. Perfect. Now let's see this. See the table now. Italy has been updated for any employee number greater than 103. So this is how you use update query. Yeah. Now your update query is also done. QRY update 1. Perfect. Now you can see this is getting aligned, so whatever we created 3 tables: table first, table projects, and then a temporary table. Then we've done with 4 queries, including select query, delete query, append query, and update query. So all this is arranged in the access objects here. Now one more thing I need to tell you, so you can even arrange it or you can even view it based on whatever you specify. Now since I've selected all access objects, it's showing like that. If I select only query, you can see only queries. So now the objects, the table objects are hidden, the tables are hidden. Or if you wanted to see only tables, you can select this. So based on the criteria. Or if you wanted to align it, based on tables and related values. So you can go for the first one, this one. See this? So based on a table, it is getting arranged. Yeah. So whatever query it's affecting a table, so it will come under that table first, TBL first. So these are the queries or these are the forms or reports that's affecting this table. So we are arranging it based on that. Now I always prefer arranging based on object type. I'm going it like that. So whichever is convenient for you, definitely you can arrange it like that. So that's one topic, which is covered in what you call 1 minute's time, how to arrange your different access objects based on a criteria or based on which query value you are using or which tables you are. Now next we are going to deal with how to create a make table query. So we have seen all the other query types. Now we are going to see what is a make table query. Yeah, what is, you heard me right, what is a make table query. Now I'm going to show you how to create a make table query. Okay, query design. From a table first or TBL first, we are going to create a new table. So you can easily use a make table with, we don't need to type in data again and again. So you can use a make table query. Now I am putting it from TBL first. There is a make table. Yeah, table name, TBL first. Okay. Now which all fields you need from this table first? I just need name and citizenship. Yeah, I'm going to run this query. SQL. Yeah, you can see select table first into new table. So it's a new table. Yeah. Okay, so there is a problem. Select TBL first into TBL first. Can create TBL second. TBL make table. Yeah. So we are going to create a new table, TBL make table, and selecting the data only the name and citizenship from the TBL first. So 8 rows will be added to the new table without any changes in the TBL first. Yeah, let's see. Yeah, we got a make table now. See this? 8 records: 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So make table, our make table is done. Perfect. Now I am saving this query as TBL make table. Make table. Yeah, perfect. Query name, right? It's not a table. So let's put QRY. So new table is created. So these all are action queries, but make table is not affecting your base table, from where you're taking the data. Or even the append, it's like that, it's appending to a new. But when you use update or when you use delete, you should ensure that you are not messing up your data, already existing data. So I always prefer you make a backup, before go with all these what you call the action queries. So that's all I have with the action queries part. Now we move on to parameter queries. So we need to create queries based on the parameters. So which I'm going to explain now. So which is, I think it's very simple now. Now you people are finding it much easier, right, to write queries or create tables or create anything. So yeah, access is actually getting simpler and simpler when you dive deep into it. So let's move on to the parameter queries now. Okay, so let's try our parameter query with select statement. Okay, so once more, we'll glance through the select statement. So here we have given the employee number as 101. Okay, so every time you cannot use the same query again and again. Okay, so that it's selecting anything greater than 101. Maybe at times you need to select it greater than 110, at times 120. So you don't need to come back and write a new query and again. So what you can do, you can just make this employee number as a parameter. So every time when you run this query, this will be a parameter. Okay, it's greater than 101, or the employee number can be made a parameter. So let's see how it is. Greater than. Now I am showing you how you can input data. Perfect. Let's try running this. Okay, what happened now? It didn't work. Why? Why? It's because we haven't mentioned what it should be or greater than what it is. So we need to mention a parameter or a criteria. Okay, so I'm just closing it. I'm not going to save it. Again, I'm going to design view. Okay, this time we are going to give a parameter, citizenship. Okay, now, okay, putting it in close brackets. Then I'm running. Mm, okay, yeah, enter value. Now in citizenship, I need only Italy. Italy. See, this is how parameter query works. See this? Now what I have done, I just put a value in brackets. Okay, so square brackets, I put the enter value for citizenship. So it's like giving a parameter. So this enter value will come as an input for people who are running this query. See this enter value, or you can specify it as enter citizenship value. Yeah, citizenship value. So it reads like enter citizenship value which is greater than 101. So if I'm entering Italy, it should be Italy which is greater than 101. Or if I'm going to run and I'm putting United States, United States, is it going to return any value? No. Even though we have one citizen as United States, his employee number, is it greater than 101? No. His citizenship is less than 101. It's 100. Hmm. If you have put Germany, definitely it would have returned a value. Let's see. Let's run and put Germany. Ah. So this is how parameter query works. So let's rename it. Let's put it as parameter query. Yeah. So we have used query select one as a parameter query as well. So the parameter query concept. So this is how parameter query works. The same thing. Let's run a query and then a project start date. So even you can mention a start date. Suppose if you are like into a project and you wanted to show that the project details based on a starting date. Suppose if it's like 1/1/2018, you can just mention it like that. Put it in the square brackets and enter the project start date. So you can see all the projects which have started in that start date. So similarly, but only thing is you need to format the exact date formatting. See here in the project start date, 21 2007. Likewise, the project start date is entered. So this is how you are like entering, or you are designing a parameter query. Now we'll move on to alternate criteria, how to add alternate criteria. So simple, alternate criteria, how to use it using a query design. So that's all. Since this alternate criteria is similar to parameter query, definitely you can try it on your own. Because of the time constraint, I'm moving to the next topic, which is actually relating your data or relationships, which is also called the data normalization. In the process of organizing columns and tables or relational database. So to reduce the data redundancy, we use database normalization. It's like organizing data in a database, creating and establishing relationships. So how to establish relationships in a database? So relationships, as I mentioned in the beginning of my tutorial, like there are like three main relationships, like one-to-many relationship, many-to-many relationship, and one-to-one relationship, okay, in a database. So so what is it like, so before getting into the practical session, I'm going to just have a small glimpse of how it is in the theoretical part. Now let's start with one-to-one relationship. In a one-to-one relationship, a row in table A can have no more than one matching row in table B and vice versa. So one employee can have only one project. In our tables, if you see, a single employee can be assigned only to a single project, or a single project can be assigned to a single employee. That's one-to-one relationship. Now, one-to-many relationship is a single employee can have multiple projects, or a single employee is assigned to multiple projects. You got it? Yeah. So that's called one-to-many relationship. Now, in many-to-many relationship, many employees will have many projects, or many projects will have many employees. There is no, it's like that. What you called, you create such a relationship and by defining a third table called a junction table. So the primary key consists of foreign keys from both the tables A and B. So what happens in the one-to-many relationship? In one-to-many relationship, the primary key in that one table, the first table, will be the foreign key in the second table, and the vice versa. Yeah. In one-to-one relationship, there are like it's not common. Okay, one-to-one relationships are not much used. The practical use is very limited for one-to-one relationship. So that's how it is, creating. Now let's move on to create relationships. So by keeping all the three relationships in mind, we are going to create our first relationship. So now I'm going to demonstrate a one-to-many relationship. As I already mentioned, let's open TBL first. So that's the employee table. TBL first is the employee table, and then TBL, sorry, not make table. TBL projects is the project table. Now the employees are allocated to different projects, as I already mentioned. Now how to define a relationship between these two? Because we have a common ID here, right? In both tables we have a common ID. So what is it? Employee number. So based on that employee number, we can connect this TBL first to TBL projects, so that we don't need to type the employee names here, or we don't need to type the employee date of birth here. Okay, so that's a major use. Or let's fill in some data first. Okay, let's complete this. Mm, okay, okay. Now I'm going to define a relationship. Let's close this. Okay. Now here you can see the database tools. So click the database tools, and in that you can see relationships define. So if you click over there, okay, now the short table wizard will open up. You need to select two tables, or where you are going to select. How you can select multiple tables too. Now as so since this is a basic practical session, I'm going to select two tables. Now I'm going to select the employee table, which is our TBL first, and I'm going to select our projects table. Okay, now I've added both. If you want to add any queries in that, definitely you can do that as well. So queries can also be connected similar to how you connect a table, or you can select both. Now for the time being, I'm selecting only two tables. Now I need to create a relationship. I need to create a relationship between this employee table and this TBL projects. For that, I have a common number, which is called the employee number. Employee number is present in here as well as here. Okay, but employee number is unique for TBL first. But here it's not a unique number. It can have multiple numbers. So I'm going to create this to this, right? Yeah, I just dragged and dropped from employee number to this employee number. And I'm going to create so one to many. So you can see the relationship type here. It's like one to many relationship, enforce referential integrity, and see this join type. So you can see all the three join types. Now only now rows with the join field from both tables are equal. Yeah. Now I'm going to create this relationship. You can see this. See this one to many relationship. You can see for every employee ID, multiple projects are assigned. So we have already created this relationship. So this is how you create a relationship. Now you can write a query by selecting a project, and you can easily connect it with the name or citizen. You can get the details just by writing a query. Now since these are connected, you can easily get it. Yeah. So that's how relationship works. Perfect. Now the tables are connected. Now if you go to database tools and select relationships, yeah, we have already created a relationship. Perfect, right? Perfect. That's how it is. So as you know that we have created a referential integrity, we have clicked enforce referential integrity, which shows that any changes in the foreign key or in the primary key will be like updated in both the tables. So it's like that, here when it's affected, the parent table is also affected. If anything is affected in the parent table in the primary key, it will be automatically reflecting in the foreign key. So that's called enforcing referential integrity. So we have done that. Now, what is this cascade update related fields? The second one that we have selected. If you select it, it's like once you make any changes in the primary key or any relevant fields or the related fields, if you make any changes, it will be automatically reflecting in the other table as well. Even for some delete. Now, this is not applicable to deletions. Okay, if you delete an employee ID or anything, it's not affecting the other field area. So, in order to enforce that, we can select the cascade delete related records as well. So that's how a simpler concept of relationships work. So I believe you people are now thorough with the relationships, at least a glimpse or you got an idea, right? Like what a relationship is, how you can enforce a relationship. So you can even use, you can Google it, definitely. Please Google, how you can write queries, select queries on tables which are related by one another, what all fields you can select from both the tables, how you can select it. So all those things are possible. So you need to take a thorough look at it. Now it's time for us to move to something else, some other concepts in Access, or not only Access, in SQL. So that's called wildcards, which I mentioned in my in the beginning of my video. So what are those wildcards? These are wildcards are nothing but special characters that can stand in for unknown characters in a text value. So these are handy for locating multiple items with similar names. Suppose if you wanted to get all the names which starts with A, you can easily do it using a wildcard search by just putting like select star from that table where employee name like A star, A and a star. Then it will return all the values which starts with A. Or if you want to know all the characters which end with A, there are wildcards like that. Or if it ends with some like John or Samuel, if it's ending with Samuel, all the names whose second name or whose name end with ND, you can do that. You can put wildcards for that. Now let's see which are the commonly supported wildcards in databases. Now star, as I already mentioned, which is actually the universal wildcard, which matches any number of characters. You can use the asterisk anywhere in a character string. Now question mark is something which matches any single alphabetical character. Now if you want to type like okay, I wanted to see Baiju, let's say Biju. So I only know Bi. Okay. Now the other characters should be what you call Ju, right? So instead of Ju, I can put two question marks. So it will return Biju, Binu, Bidu, Bifu. So whatever it is, after Bi. So as you see here, B question mark LL will find or will return the values like BALL, BELL, and BILL, right? Match any single alphabetical character. A, E, I. So if there are any other matches like B, Z, L, L, definitely it will return that. Now, any single character, you can use single braces, B, this will find ball. So now question mark will return all the characters. It can return BALL, BBLL, BCLL, BDLL, BELL. Now if you want to return only BALL or BELL and BALL, you can specify those two characters here. So that's in the square brackets, B square brackets AELL. So it will return either BALL or BELL if there are values like that. Similarly, asterisk, you need to search, what asterisk is, match any character not in the brackets. It's opposite or reverse to this one. Yeah, it's a negation of this one. So all the characters which are not equal to AE. So it will find BILL, BULL, but will never figure out, BAL. Likewise, match any single numeric character. So then there are characters like percentage. Now percentage finds WH percentage will find WHY, WH, any number of characters. It doesn't matter the number of characters after WH. It will return anything. Yeah. So this is how you figure out wildcard characters. I think we can go with a single example, or I don't think it's necessary because we have already shown you like how you can use star to search, based on a character, how you can select. If it's citizen Italy, we can select IT and star. Definitely all the citizenship of Italy will be like shown. Yeah, Italian will be shown. Yeah, that's how it is. So now let's move on to our next session. Now let's move on to another important topic, after wildcards, it's calculated expression. So you might wonder what is calculated expression. So calculated expressions are nothing, uh, but they're like a formula in Excel. So Excel, you might have used formulas like some formula based on a value, two columns, you sum the value. Similarly, you can create a column which actually is a calculated one based on two different other values. So expressions can be used to perform a variety of tasks, from retrieving the value, a control, or supplying criteria to a query. So as an example, let's see. Okay, let's take how you can create a calculated column based on the values from two other columns. Okay, let's move on to our database now. Okay, now let's redefine our projects column. Okay, so in that we have created some budgets. Okay, okay. I'm redefining this column so that we can have a calculator column. Okay, I'm redefining all the values. Okay, now I need to have what you call. Okay, I'm going to say per hour value or per hour rate for each employee. So in the first column, DBL1, we need to have, or of course here, for this project, per hour value, how much it is. So the budget is 4,000. Now the per hour budget or per year budget, let's say. I'm thinking how how I can do this. Yeah, budget is currency. Uh, now per, now let's say resource cost. Perfect. Resource cost can be again currency. You can change the currency type. Okay, I'll show you how you can change the currency type. Now let's go with this currency only. Resource cost. Okay, now the resource cost can be 100, 200 for 200, 102 it can be 120, 100 it can be 111, 102 it's 120. Yeah, so we are almost done with it. Now to calculate the total project cost, we need to add the budget, for this project as well as the resource cost. So addition of both these will return the total cost of the project. So that's how, for that total cost, we are going to use a calculated column where it adds or sums up the budget as well as the resource cost columns. Resource cost. Yeah. Now let's see how we can do that. Okay, so now let's create a calculated column. Now we'll go to design view. So I'm going to put a total cost. So this total cost should be, the data type should be calculated. Now click select this calculated. Now the expression builder window will open. Now we need to select from the table projects. Uh, so while clicking the table projects, you will get all the table project columns. Okay, so from this we need to add budget as well as resource cost. So I am double clicking budget. Now it's added to the expression column. I'm adding a plus sign. I'm adding both budget plus resource cost. Perfect. Now I'm clicking OK. Now the calculated column is ready. I'm just saving this table. I'm putting datasheet view. Perfect. See this? It's calculating. Now project, any project you add, 103. Yeah, 103. It can be 100. See this? It's automatically getting added. Yeah, perfect. So this is how we use calculated columns. Similarly, you can use the same calculated expressions in queries. Queries can be used to have calculated expressions. So in a query, if you write a query and put it like in a subtotal, okay, table or order details into, so you can put a different, expressions like plus for addition, multiplication, you can use star. Uh, Likewise, this is how you refer to different. Now we are done with that. Let's move on to one of the most important fields or concepts in SQL or in databases. It's called indexing. So indexing, I'll just put it in a nutshell. Indexing is nothing like, similar to your table of contents in your book or or index in your book. So you don't need to search the entire records to get a result. So for that, suppose if you have names from A to Z, you will have in the index the names which starts with A, names which start with A, B, C, D. So that will be the index. Suppose if you are going to select Annie, or what you call Aish, AI is AISH Aish. So if indexing is there, the record search will go directly to A. So it will search the index, or what you call the table of contents first. Go to A, then from A, the next field will be AI. It will go to AI, then we'll select all the AISH. So indexing is similar to how in your books you have the table of contents or the first what you call the first pages, where you refer to and go to the particular search criteria. So rather than searching blindly throughout the record, so if there are like a million records, it's almost impractical that you search for all the records and then retrieve the value based on that. No. So for that we will create indexes. Based on some criteria we'll create indexes. Now if you ask me, okay, whether you are creating indexes, yes, unknowingly you have created indexes. So that's called primary key. So primary key, if you set some field as a primary key, automatically it's indexed. So that's the reason why while setting a primary key is one of the most important things that you should do while designing a table or a database. So when you select a field as a primary key, automatically it's been indexed. So okay, you can see this. Now this employee number is the index here. Now go to this design and then you can see indexes. Display the list of fields on which the table is indexed. So other than the primary key, suppose you wanted to index on the name field, definitely you can create indexing on the name field. Okay, now since the primary key is automatically indexed in the ascending order, now you need to create another index. So which index you should do? Let's say name. Yeah, index name can be name for index, name for index testing. perfect. And selecting the name field. So name field is getting indexed. It's not a primary, it's not a unique, it's ignoring nulls, yeah. And I am creating this indexed ascending order. You can also put it descending order. So the names will start with Z. So if you are searching a field or searching a name which starts with X, Savior, for example, Savior, if you have put it as a descending index, it will retrieve the value faster. Got it? Rather than ascending. So likewise, now we are putting it as in descending. Okay, let's put it descending. Hmm, done. Now you see this indexing has been done for both primary key as well as this one. Yeah, cool. Now you can delete the index as well. Right click, delete rows. You can delete the index you have already set. Each index can use up to 10 fields, the name for this index. Yeah. Now the data retrieval will be much faster. If you have 1,000 names, since we don't have many records now, you couldn't find much difference while you use a select query for names. Now that significant difference you can see while you put or while your table has more than like a million records. Definitely you will find a significant change in the number, or it's change in the time that you are given for querying. Suppose if it's taking 30 seconds, usually while after adding the index it will go down to like 3 to 4 seconds. So that's the power of indexing. And I'm not going to delve deep into indexing. So since this is a basic thing, that okay, Access has already implemented indexing for all the primary keys or foreign keys, so you don't need to specify it in the other manner. Definitely indexing is a good concept. You should always have that in mind while selecting indexing. Yeah. Okay. So even in indexes, you can delete off any duplicate. So indexing doesn't mean that you need to have duplicate values in the index. You can specify that you don't want any duplicate values in the index. As I already mentioned in that window, there are options like that. You can select that, and in the index, no duplicate values are added. Only unique values will be added in the index, and based on that, search criteria will work. So even that's a powerful criteria or a powerful concept, in SQL. In most of the SQL RDBMS databases, indexing is more commonly used. So once you have the power of indexing, the database design will be more usable, more user friendly. So people will have lesser query timing, so they can query in like, in seconds than compared to minutes, or, what you call 10 minutes, 5 minutes time. I've seen some people querying, and it's taking more than 5 minutes or 10 minutes time, and they are waiting for that query result to come. So I've asked them, okay, why don't you index the field that you wanted to retrieve the data? So indexing can drastically change, or the way that you design your query, you optimize your query definitely. And then, so optimizing means, it comes to normalization, data can be like, put it in ascending order, descending order, then indexing it, relevant fields. Doesn't mean that you should over index it. If you over indexing it, there is a problem as well. Again, the query time will be like more. So instead of having a positive impact, it will have a negative impact on your query timing. So don't index too much. So one more, what you call, an advice or a statement that I had to make, because I've seen people over indexing, believing that okay, it's going to reduce the time, a hell lot of time, but instead it will have a hell lot of time in the query. Yeah. So please don't do that. Please don't over index. So if you have a primary index field and then a secondary index, that's fine. That's enough. That's more than enough, I would say. So that's with the indexing. Let's move on to the next topic, which is actually grouping data. So grouping data is it's like, we need to group data based on some criteria. Maybe if you want to find the sum of all the project cost, total project cost, you can do that. Or the average of all the project cost, you can do that. Or if the average of some values, you can do that. Minimum of the project cost, you can do that. Suppose if there are like 100 projects and you wanted to figure out which project is costing minimum, or second minimum, or third minimum, or which project has a maximum budget, you can do all those things. And even counting the number of projects, unique projects or unique employees in that project, you can easily do that. So you need to define it, based on different criteria. So I'll illustrate, how you can do that. Let's create a query first. Query design. I'll go to query design. I'll be selecting. mm, I'll be selecting what should I select? Projects, definitely projects. Let's say I'm going to select star from table projects, or select count of, what do you call, project name. No, let's employee number. Let's take employee number. Will it run? Let's see. Yes, there are 7 employee numbers. So as per our query, it's returning that there are 7 employee numbers in the projects field. Is it right? It is right because we have 7. 1, 2, 3, 4, 5, 6, 7, right? Are they unique? No, because we know that we have employee numbers duplicated, or multiple projects are being assigned for a single employee. So how do we find that how many employees are allocated for the total number of projects? So we need a unique value. So let's redesign this query. Select distinct count. Distinct. I'm putting a distinct function here and count employee number. Let's run it. What happened? Distinct employee number. See this? Distinct. So you got all the four: 100, 101, 102, and 103 are the distinct employee numbers. So there are only 4 employees which are assigned actually to all the 7 projects. Perfect, right? So this is a grouping method, where you can seriously, it's something very, very important, very important once you are dealing with day-to-day query lives, SQL in your day-to-day activities. Definitely, this is very important. So let me rename this query as, query for what you call aggregate query aggregate one. This is even though it looks simple to implement, it takes a lot of time. Okay, since I am used to it, definitely I could get it easily, but since if you are new to this, you'll struggle a bit in the initial stages. So I prefer you people try with this count, sum, and all those functions. Let's see, I'm going to design one more query to showcase the project budget. Yeah, select sum of what do you call total cost. Total cost from table projects. Let's see, let's run. We got the sum 89,951. Perfect. So it's calculating all the values, total cost. Similarly, you can type in the minimum, select minimum of total cost. We'll see a project which has a minimum value 2,100, but this is not perfect, right? So you need to select the project name as well. Only then this will have some what you call add some value, project name comma minimum. Project name doesn't exist, so what is it? Did I misspell it? Yeah, project underscore name. Select project underscore name. Hmm. Why this is not working? So that's what project name as part of an aggregate function does not include. Yeah, so we cannot write like this. Let's do one more select project name comma total cost. Total cost, right? From TBL projects where it's again returning syntax error. So what is the problem here? Select project name total cost from table projects. Okay, so I've redesigned the query like this: select project name total cost from table projects where total cost equal to select minimum of total cost from table project. So it's going to return the project name as well as the project cost, which has a minimum or the least project cost. So let's save this query and run the query aggregate, right? Two, aggregate two, and run this query. I got the project which has the minimum cost, project G. Let's see whether project G is the one which has the minimum cost. Perfect. Similarly, you can write it for the maximum cost. I hope you got it. This doesn't look easy, okay, I know that. For me, it was very easy because I'm used to it. Once you are used to it, you know how to write this, what you call the multi-level queries. So I've used two select queries, where the select query is first select query is taking the name and the total cost from table projects. However, the second criteria is where total cost equal to, where this total cost is equal to the minimum of total cost from the table query. So it's called multi-level queries, similar to how you have multiple if functions. On if function, based on criteria, another if function inside, looping of select queries. So this is also called looping of queries. I hope this is actually good for you to learn, in your initial beginning phase. It's really good, to have these concepts ready. So we are done with some of the queries, some of the aggregate queries here, or aggregate functions here. I've shown you demonstrated like sum, I demonstrated minimum, and maximum is also similar. Then I demonstrated count and with some distinct values how you can use it. So I believe that aggregate functions are taken care of now. So there are n number of aggregate functions that's easily available. You can search in Google, what are the aggregate functions that's available in SQL and for different databases. Maybe if it's SQL Server or MS SQL, MySQL or Oracle or MS Access. So different aggregate functions are there, and there are different methods by which we should use that functions inside all these all these languages or all these databases. So for MS Access, it will be different, slight differences. If you know one concept or one database, one RDBMS. So if you know MS Access thoroughly, it's very easy for you to design it in like MS SQL Server or it's in Oracle. The concepts are similar, only some notations here and there, so some symbols would be different or some formatting would be different. So that's only different. So the underlying concept for all the SQL are like same. So let's move on to next section. Now the aggregate query is done, so it's one of the most important sections too. Okay, so always keep this in mind that you can have calculated columns similar to how you use Excel. You can also have this in your queries. So now in grouping data, another concept is concatenation. So many of you might have heard about this concept called concatenation. It's called combining two fields or combining two values. So how do we use concatenation in Access? So that's what I'm going to illustrate to you now. So concatenation in Access. So there are two different operators where you can use concatenation. It's ampersand operator as well as plus sign operator. So you might have used this concatenate function in Excel as well as this ampersand operator in Excel. Similarly, we have the same concept, in Access as well. So I am going to demonstrate to you, how you can use this concatenate function or concatenate operator to concatenate or to combine two fields in Access. Okay, let's select first. Let's create a simple select statement. Then we'll show you how you can use the concatenate function. Run the table first. Okay, let's select name, name and citizenship. Okay, we have selected name and citizenship. Now I need to concatenate uh, and put it into a new column, which should actually show both name and citizenship together. You can use, if it's like a last name and first name, you can do the same thing. Okay. Now I'm naming that new column as name and citizenship. Name and citizen. Putting a dot here. Then I am putting name, ampersand, citizen. Okay, let's run this query. Perfect. John from United States. Now it doesn't look good, right? So John without any space. Now let's go back. Name, ampersand, citizen as name and citizen, right? Name, name and citizen. You can even design this in query. Okay, now let's move to design view. Name ampersand, then again an ampersand. Let's run this now. Yeah, what I've done, John space United States. Similarly, first name space last name, right? So it should come as a full name. Similarly, name and citizenship came together with a space now. What I did was I just added a space character, double quotes. See this? This ampersand, now first citizen, name ampersand, uh, in double quotes I put a blank, then again ampersand citizen as name and citizen. That's it. Now you got the results, you got your desired results. Now let's rename this query as QRY concatenate. Perfect, right? Awesome. This is really awesome. I know that you are getting more the concepts more and more clear. Now we are moving much more deeper into the concepts of SQL, how you can use different functions, how you can use MS Access. It's getting more and more complex. I know that, but it's getting more and more interesting as well. People who are, but the thing is, you should actually follow it from the beginning of the tutorial. You shouldn't skip any part. If you skip a part, it will be much difficult for you to understand. So I recommend, or I prefer, you please go through each and every section before coming into this. Don't just jump from the initial 10 minutes to this 1 hour. Please don't do that. And if you are, definitely, if you are an advanced user, definitely you can use that. Okay, but for beginners or intermediate users, please go through the video sections one by one. First 10 minutes, then 10 to 20 minutes, 20 to 35 minutes. uh, go through each and everything, because I've designed it based on that. Even for advanced users, you can use this. So I prefer you go from each and every section one by one. Please don't skip levels. Okay, skip level will definitely make you more confusing, make the video more confusing. So going forward, it's getting more and more complex. I'm going to design macros in Access, how do you automate different tasks. So I'm going to help you guys do that. So let's move on to the next topic, that is summarizing data. So how do we summarize data in Access? Uh, so there are, there is a different section in Access database which actually pertains to the summarizing. Okay, now for that we can create a query wizard. Using query wizard, we can create a query which actually summarizes the data. So let's see how we can summarize data. Okay, now let's take query wizard. So in this summarizing query, so you might see like simple query wizard, close tab query wizard, duplicate query wizards, and unmatched query wizard. So here, let's start with the duplicate query wizard. So what this is, this wizard creates a query that find records the duplicate field values in a single table or query. So in order to find a duplicate, so what can we do? Okay, let's select that find duplicate query wizard. I'm selecting it from which table? Let's say projects table, based on which value. So we are going to see whether there are any duplicates in the employee number. Okay, and we are selecting what all fields should be highlighted if there is a duplicate. For the duplicate result, how many fields, or what are the available fields that should be displayed. Let's select all the fields, then clicking next. Find duplicates for TBL projects. Okay, let's name it like that itself. Finish. See this. So if you see, so there are duplicates like this. Okay, for 101 you can see 2. 102 there are 2 records. 103 there are 2 records. So this is how you can summarize data. Duplicate. So this is one example, and let's save this as this itself. Now the next one is the cross tab query. Okay, so this is an interesting one. This cross tab query, it's similar to like a pivot in Excel, where you can summarize data based on rows and columns. So let's see what it is. Cross tab query wizard. I'm selecting this, and which table or query contain the fields you want. Okay, let's select the TBL first as well as the TBL projects. Okay, let's start with TBL first itself. Okay, now I'm TBL projects. Okay, let's select TBL projects. Now which field values do you want as row headings? As row, which all fields you want? Okay, I want row headings to be like project ID. Let me keep it. So employee number, no, project name, I'll keep project name. Project ID and project name, I'll keep it as like, headings. Now, next, which one you do want as column heading? Okay, let me select total cost. Okay, total cost. Do you want to summarize each row? Yeah, because it's a cost, let's summarize it. Clicking next and finishing it. See the cross tab query. Hmm, perfect. So this is an example, okay, where you can create a cross tab query based on that, based on project name, total employees, and for each project cost, how much, resource cost is allocated. So for 103, you can see this, So for this one, it's like 102. Likewise, you can try and figure out, what all fields or what all methods you can use to generalize. So it's just a test phase that I'm going through. So you can create much more complex queries and cross-tab generalizations as you wish for. So that's up to you. So you can just try play around with it. Now let's move on to the next section, that is joins. So what is a join? Since you know that database is a collection of tables of data that allow relationships or logical relations to each other. So you use relationships to connect tables, right? So a table can be part of any number of relationships, but each relationship always has exactly two tables. So in a query, a relationship is represented by a join. You got it. So join specifies how to combine records from two or more tables. So if there are like two records, two tables, and you need to combine some records from both the tables, but based on certain criteria. So how do you combine all those records? What kind of queries that you use so that you get the results from both the records, based on some criteria. So for that we use two general types of joins. That's the inner joins as well as the outer join. So the most common type of join is the inner join. As you see here, there are two tables, represented as circles. So out of which the joins return the inner join return only the common one or the common records, which is present in both the tables. So that's the reason why this area is actually shaded. So if you see here, this area is the common area or where there are records common to both the tables. So that's how an inner join works. Now outer join works in a different manner. So outer join will discard the unique records in the first table and will take the unique records in the second table as well as the common records. Hope you got it. So if you see here, this area, this blank area is what are the records which are unique to that particular table or the table one. Now this area is actually the unique records pertaining to the second table as well as the common records. So that's the difference between outer join and an inner join. Hope you got it. Now there are multiple types of outer joins like left outer join and right outer join. Left outer join, it's like it will take unique records from table A as well as the common records. Now the right outer join is vice versa. So hope you got it. Now how do we connect? How do we connect or how do we design joins based on queries? So let's see how we do that and let's illustrate some examples so that you can understand much clearly how you can work out with joins. So let's do that. Okay, let's start by creating a query design from both the tables. I'm selecting table first and table projects, adding it. Okay, so as you know that it's connected by one-to-many uh, relationship. So hope you know that. Yeah. So we have already discussed that, how to create a one-to-many relationship or one-to-one relationship. So we have connected it based on the employee number. So employee number in both the table TBL first as well as TBL projects. So let's illustrate it first. Okay. Now I'm creating this line, which is connecting both the TBL first and TBL project. So one-to-many relationship. I am selecting this. So in this you can see that left table name is TBL first, this one, and the right table name is TBL projects. Now left column name we are like employee number and employee number in both the fields. Now inner join means only include rows where the join fields from both the tables are equal. So that means it's a inner join. So the first one is inner join. If I click OK, I'm including only those records. If I'm going for a simple select statement, it will be showing only those records which are at least one destination. So select, let's select star. Yeah. So common records. So these are the common records in both the fields. I mean in both the records. 101 and okay. View. Let's move to design view. Yeah. Now let's see the second one. Include all records from the TBL first, and only those records from TBL projects where the join fields are equal. This is the left outer join. So this is the left outer join. And now if you select this one, this is the right outer join. That is including all the records from the second table as well as the common records. So this is the right outer join. So left and right outer joiners are given here. Okay, now let's see what if we select the right outer join and see. Yeah. So this is how it differs. Okay. Hope you got it. You know what we mean by left outer join and right outer join. Yeah. Now let's move on to the next section. I hope you people understood and got a fair idea on how these joins work. So these joins can also be designed using SQL queries. So in that, you know, you need to specify join, inner join, left outer join. So all those wordings you need to create. So just Googling, you know, how to write joins using SQL queries in Access. So definitely you will get it. You'll get an idea on fair idea on, you know, how you can write it. So if you write here this, the right join, select star from TBL first, right joining. So here it's right joining TBL projects on TBL first employee number. So on this field it's joining based on right join or right outer join. Similarly, you can write it, you know, based on the criteria that you have. So that's how joins work. So let's move on to the next section. So in Access, there is one more interesting thing is unmatched query wizard, you know. So it's a very useful wizard and it's finding unmatched query. It creates a query that find records or rows in one table that have no related records in another table. You got it. So whatever fields that are blanks, you know, it can return those. So unmatched queries, there is a wizard for that. We'll go creating now. Let's create a query wizard. Unmatched, find unmatched query wizard. Okay, now which table of query contain the record you want in the results? So I want the projects to be in my results. So which table of query contain the related records in the first TBL first? Definitely. Now which piece of information is in both tables? It's employee number. Definitely it's the employee number which is present in both the tables. Now which field do we want to see in the query results? All the fields. Let's see let's see unmatched. Nothing is unmatched. So all the employees are matched to one project, at least one project. Now if you type a new employee, okay, if you enter a new employee, EMEA, or with an employee ID here, Italy, with the date of birth, let's take it. Let's see if anything happens. Let's see if anything happens now. Right, I'm running. Definitely you can't see anything because it's still everything is matched in the project. Now if you assign a project, now hope you are going to see the example here. Now if I'm project Z, I'm not going to match any employee number here, and here I'm going to use this. You cannot. Yeah. So unmatched query result is not possible now because you need to have a relation in the TBL first. Now there are no unmatched query now since we are already connected it using a relationship, and every employee should have any even a single project assigned to them. So the unmatched query wizard won't work now. So it will work the reverse way. So whatever we are selected won't work, but it will work the reverse manner. I'll show you how it works. Okay, I'll show you how it works in the reverse manner. Now I'm closing this. I'm going to create a new unmatched query. This one. Which query contain record that you want in the query result? Of course, TBL first. Which table query contain the related records? TBL projects, employee number, everything. Next, finish. See this. So these are the unmatched results. It means that all these assignees are not assigned to any projects, not even a single project in the TBL projects table. Let's see. 104, you can't find 104. 105 is not assigned to any projects. 107, no. 122, no. 124, no. So this is the usefulness of unmatched query wizard. Hope you got it. So you can see how many employees are not being aligned to even a single project. So that's the usefulness of unmatched query. Yeah. Now, when you think about the real world applications, real world usages of all this, you'll be surprised. It has a lot of implications. It has a lot of applications in your day-to-day life. Even when you assign a project, you need to know how many people are sitting idle. Now, if there are like 1 lakh employees and there are like 3 to 4 lakh projects, and how do you figure out, how many employees are sitting idle? And since that project is over or expired, that person will be released. So how do you come to know that, that person is released? Definitely not by manual searching. So you can use this unmatched query and see whether that person is who all are like sitting idle, and you can assign new projects for them. That's just a simple example. Maybe in the real world, it will be different. Even for a 100-member team, that's really relevant. Being a project manager, you need to figure out who all are assigned to what all projects. That's the application of this unassigned, unmatched query wizard. So So after completing this, we are now in the end of those unmatched query wizards and join. So now let's move on to the next section. So we are going to move to the form section. Yes, you heard me right. Now we have completed uh, tables. Now we have completed the queries. Now we are slowly moving to the next section, that's forms. Now we have 2 more sections to complete after this, that's reports as well as macros and code. So all these sections are properly aligned here. If you see here, this is the table section, query section, form section, report section, and macros and code section. So we are moving to each and every section one by one, without without in a hurry. We are not in a hurry, to complete all those things so that, you people uh, find it difficult to adjust, to the learning modules. So I'm going slow, taking one step, baby step at a time. Now we are going to move to form. So what is a form? Form is actually a user interface. Form is actually a user interface. You heard me right. Yeah. So now forms, it's like, in Access are like displaying cases in stories that makes it easier to view or get the items that you want. Now, since forms are objects through which you or other users can add, edit, or display the data stored in the tables or in your queries, so there are 2 types of forms like bound forms and unbound forms. Bound forms are connected forms actually. As the name suggests, it's bound to something. What is it bound to? It's bound to either a table or a query or an SQL statement. Bound forms are what typically people think of when they think of the purpose of a form. Forms are to be filled out and used to enter or edit data in a database. Now you cannot present the tables as such to the users who are using this database, right? There is a chance that they may mess up with the important data. So you need to present only the relevant information for them so that they can edit some fields, the relevant fields, and they are not allowed to touch or not even able to view. They shouldn't be able to even view some other fields. So for that purpose, we use forms, okay? So that only a part of what that underlying tables are is displayed to the end users. For that, we use bound forms. Now, what are unbound forms? The forms are not connected to an underlying record or a data source. It could be like a dialog box or a switchboard or a navigation form, even some macros, maybe a login macro that you have generated. Suppose you created a login macro where users are logging in and it's getting registered there. So even that's an unbound form because it's not getting bound to any tables or anything. Of course, login forms are bound to some, login tables. I'll explain in detail, how you can create a login form, and register users activity in that. So that will be coming in my next videos. So now let's stick on to the basics. Let's move on to forms first. Okay, let's create a basic form now. So single item form, this is the most popular one and where the records are displayed, one record at a time. Single item form. So let's start with the single item form first. Yeah. Now you can see 3 sections out here, mostly. Form, form design, and blank form. What is a form now? Form creates a form that will list an information for one record at a time. So single record form. I'm clicking the form. it's bound to TBL projects now because I've selected the TBL projects and clicked the form. It's bound to TBL projects. Now I need to design the form. Okay, I don't want people to see the total cost. What is the use? I'm just deleting it off. Yeah, and I'm making this extra notes. Yeah, and one more thing, I'm can do so many things, in forms. Project ID shouldn't be editable, right? Should it be? No. So let's start with that. I'm creating form properties, data. So you can see so many properties, associated with the form thing. Okay, project ID is a text box. So you need to have people view this form, but you should limit people from accessing it or editing it. So what should we do? We can just lock it. So I am going to lock it. Okay, in the data section, once you create this project ID text box, you can see a data section, format data. In that there is a locked. I'm clicking that as yes, locked. You can also write some validation rules, and also I'll explain it to you later. Okay, input mask. To provide an input mask. So text or date field types. No, it's working. Okay, let's see now. Form name is FRM. Now we are just naming it as per the convention FRM projects. Okay, form view. See this? I can't edit one, but I can edit NA. I can put as new value. Okay, now let's see the projects table now. NA would have now become new value. What is it? Yeah, where is the new value now? Extra nodes NA, extra nodes for TBL projects. Which project ID? 1. Project ID 1. Okay, yeah, so nodes. Let's move, save, close. See this new value? Yeah. So whatever changes you made in the form, it got automatically reflected in the underlying table. So that's it. So we have just made this one uneditable. See this? I'm getting some warning messages or sounds. Look, it's not editable. Now automation can be edited. So all the other fields can be edited. So likewise, this is actually a single record form. You can only see one record at a time. So if you see here under this records, how many records are there? 8 records. So 1 out of 8. I'm in first record out of 8. You can just go one by one, or you can just directly go to the last record or first record. Even you can create a new record here. So you can disable this button based on your will in the property sheet, so that people are not able to create new records if you want them to. So you can just play around with the design view and then the property sheets, or add existing fields. So many items are there, so you can uh, allow filters, allow edits, so many things. So if you don't want people to edit not even a single item in this form, just put this allow edits as no. Done. Allow additions. If you disable this allow additions and then you save it and close it, you open it. See this? New record button is being grayed out now. Yeah. Similarly with deletions as well, you cannot delete. So that's how a single record form works. Now let's move on to much more complex forms, multi-record forms and all those other forms. So let's move to that. Now let's create another type of form. So I'm going to create here, select the form wizard, uh, maybe TBL projects. Okay, let's take TBL projects, selecting all the fields. Next, which layout you like? Tabular, datasheet, justified. So let's take datasheet, TBL projects. Let's make it FRM projects, right? Okay, FRM projects 1, FRM projects split or multi-record. Yeah, see this. So this is a form. Yeah, this is a form. So you can change the background color in this form, or alternate row color. You can make, or any conditional formatting styles. Yeah, as you wish for. So this is a multi-data form, where you can see almost all the data that's there in that particular form. You can edit it based on the, whatever you need. So similarly, you can do the design view, go for it, and in the design properties, you can select, which all fields should be editable and which should be non-editable format. So you can align it, you can even put a record log so that no records are unnecessarily edited. If it's not something that you want people to edit or users to edit, they just want to view it, you can make it like that, as I already mentioned. So this is how a multi-user form works. So I'm just saving and I'm closing it. Now let's take one more example of a form. Okay, now in a form wizard, so there are other forms like navigation forms like horizontal tabs and vertical tabs left, vertical tabs right, this that. So what, so let's see, there are like n number of forms, navigation forms, from which goes from one form to another, which moves from the other form to this form. So navigational forms are something that are very useful for you. So if you are designing a massive database, where there are like n number of forms for different areas or different countries, and from one country to another, you need to move in just after a click, you should move from one form to another. So under such circumstances, such forms are really useful. So that's about the forms. Forms are a deeper topic. If I start stressing out on each and every form that's there, or the customizable forms, definitely it's going to take at least 3 to 4 hours. So I'm skipping that part. I'm going to post a video which is devoted only to forms, in Microsoft Access, which will be useful for you guys, so that you know how complex forms are, what all designs are there in the forms, how you can design a customizable form, which is not part of the Microsoft standard library. So even that will be posted in my next video. So now let's stick on to the basics and we'll move on to the next section, that's reports. As you know that after this, so we have covered tables, queries, forms. Now we are moving to reports. Now reports, as the name suggests, is something that you want in a reporting format or a report format. So how do you get it? So let's click report design or a single report. Now let's create a basic report first from the form project. So you can either create a report from a query, from a table, or a form. So you can create a report. So this is how report it is. Report looks like this. You can add a date and time. Yeah. So see this, 18th August, the timer is going on. Page numbers you can put in the report. Header, uh, title you can put, report one. Even inserting an image, it's possible. So many things, you can change the format, control wizard, grouping and sorting. The fonts you can change. So this is how report works. Okay, when the total, whatever it is, it's displayed here. The total is displayed separately. So this is the basic report design. Now let's take RPT report. Now one more report, let's see. So similar to how we have form wizard, we have a report wizard. You can select it from table, let's say table first, employee table. I don't need the ID, I just need the name, employee number, citizen and date of birth. Perfect. Do you want to add any grouping levels, based on what it should be grouping? Let's group it based on citizenship. Yeah. Now let's see. It's a single level grouping. Similarly, you can have multi-level grouping as well. Next. Okay. No, let's make it portrait. RPT first. Finish. See how the report looks like. So we have grouped it based on citizen. So for France, you have Vic. For Germany, you have Christian Manuel. Italy, you have Core, Danny, Inia, Jim, Lucy, and for US, you have John. So, and their employee numbers are displayed here. So you can just go for a design view and you can align that. So this is not properly aligned. Just align this. No issues. It looks much better once you align. Yes. See this employee number, even date of birth, you need to align it properly. Mm, okay, perfect. See this. Now you can generate reports like this. You need to play around with the reporting section now. Since because of the time constraints that I'm just limiting the tutorial to the basic reporting things. That's it. Now I'm moving to the next section, which is nothing but how you can import different different formats, or what are the things that you can do while importing things. Now you have database tools and external data. Now what is this external data? External data, suppose if you have an Excel sheet with the CSV format, or Excel format, you can select that. From file you can either select Excel format, XML, text file. Even from text file you can get it, comma separated values. CSV format you can take. Even from another access, you need to get some data, you can just connect it, from another database, access database, from SQL server, from Azure. Of course, that's a great thing, from Azure database, which is actually the buzzword in the corporate world now, the Azure database, and DBAS file as well. Now, one interesting thing about access is you can directly connect it to SharePoint. Perfect. Now as you know that you have tables here locally, right? These are local tables that you have created in your desktop or in your machine, local machine. So what if you need to have these tables in a cloud, in a cloud server? So for that you have the option that Microsoft provides using Microsoft SharePoint list. So if you have a SharePoint server, or if you have a SharePoint site, you can create a list over there and connect that list. You can create a SharePoint list here. Since I have many SharePoint lists connected, I'm not clicking it now because that's going to be some issues. It can cause some issues because it's not connected now. So SharePoint list you can connect from Dynamics 360, another Microsoft product, then from Salesforce site, and from other data services, and from other sources like DBC database including SQL. Then maybe from an Outlook folder you can connect. So all the folder items are listed here in the Access database. So even Microsoft Outlook, even the mails, coming from different mailboxes. So there are multiple accounts set up in your Outlook. So in that case, you can just use Microsoft Access as a, what you call it, as a control source, as a coordinator for accessing your mails and replying it, auto reply. So everything can be set up using macros here or codes here. So that's another power that Microsoft Access offers. And I believe after 2013, this was more prominent. Yeah. So now we are moving on to our final chapter, which is nothing but creating macros and code. Yeah, you heard me right. So this is one of the most important feature, or the powerful feature that's provided by Access. Now the underlying code is in VBA, similar to Excel. If you know Excel VBA, this is almost similar. I would say that it is at least a 90 to 95% similar. 90% is similar to Excel VBA. So if you know how to design macros in Excel, definitely you can master it in Access as well, because I've created many VBA code which automated many tasks, including data entry, or once a person enters a data, the code automatically checks the data, and based on that input, the code will enter the data in some other table. You got it right. So if a person is entering hi, it shows that it's a welcome message. So based on that, uh, another table is filled which shows that okay, a new person has joined. So similarly you can write or automate in many tasks. So I'll just show you the code module like Visual Basic Editor. So this is the Visual Basic Editor that you have, and for the test base, similar to how you have the Excel, you can insert a module, and you can connect it here. You can do so many things. It's really powerful. Even you can create a class module. And one interesting feature with Access is auto exe code. Okay, so auto exe code helps you to automate many tasks, even starting tasks. So whatever code you write in that auto exe module, it will be automatically generated or run. Okay, so I'll show you how it is done. A simple thing. uh, you have a module, you have a class module, you have a macro. Even in reports or underlying reports, you can assign macros. See this in RPT first. I'm going to take design view, property sheet. See this event. You can write an event as a macro builder, expression builder, or a code builder. If I click a macro builder, on the report, I'll say that mm, close the database. On current. No, let's refresh the database. Okay, say refresh. Perfect. Saving, I'm closing. So on current or on loading we can write, or on no data we can, on click we can write a code. So this macro code can be incorporated into these queries, into these forms, and into these reports, in the property sheet. So this is one superpower that Access offers to you guys. So by this, I'm reaching the end of my first training session on Access database. So this is just a basic, for beginners as well as for advanced users, how you can design. Now, what I'm planning is on the next session, I'm going to come up with more macro modules, how you can design complex access tracking macros and all those codes, which will be incorporated into this. Moreover, I'm also planning to have a SharePoint uh, and Access connection, SharePoint to Access or Excel to Access or Power BI to Access. So many other things, so many other things are coming in my mind, which I'm going to be posting in the coming video. So please subscribe to my channel, and thank you guys. Thank you for watching. Thank you for patience. And I hope you guys enjoy this section well. So keep subscribing and keep watching, keep learning. Thank you. Thank you so much.